execute those. We have an expression language for manipulating and data and that kind of thing. We are hiring. So if any of that platform, low-code platform interests you, check out appian.com/careers. And you can look for a bunch of job openings in engineering department as well as across the whole company. We have job openings in security as well as quality engineering, as well as across the spectrum of things you might be interested in. So again, appreciate you coming out. Enjoy talking about DevSecOps stuff, which is actually something we're embracing as well. So very good.
I'm just going to have a 30-second spiel.
And you'll have to be close to this if there are people over there. Because that's it right now.
Sorry, the microphone. Sorry.
Yeah, if they can actually hear us over there.
Yeah,
If they can.
I actually just went in that room and the audio is very good.
Good.
So hi, I'm Cynthia. I'm actually one of the co-organizers of this event. I actually organize DCAST, which is separate media group. It's focused on agile testing. So security testing, I think, go very closely hand in hand. So we're always looking for speakers. We're always also trying to present really helpful content around advancing testing all around. So if you actually are interested in presenting, we are always looking for speakers. You can find us on Meetup. We also have our own website. We have a bunch of swag. Please take some, because I don't want to take it home. Take a sticker. We have hand sanitizers, because you never know. It's DC, you're on Metro, it's gross. So, but thank you all so much, and thank you very much. And I'll hand it over to you all.
Sure. Thank you. So we have to step over here if you want to be heard.
Yep.
All right. Yeah, thank you everybody for braving the elements to make it out here. Was not expecting that. It was supposed to be a nice clear day, smooth sailing, but so much for that. So again, thank you to everyone who made it. Just a couple of things to go through. We aren't having a meeting next month, but we will have one in August. It's scheduled for August 15th right now. And it will hopefully be here. We'll see.
Well, not here.
Tyson. Sorry, Tyson with Appian. So we're still trying to figure out the logistics of that for the near future. And then we are still ramping up for the OWASP Global AppSec DC conference, which is scheduled for September 12th and 13th. And then there will be 3 days of training prior to that. So that's the 9th, 10th, and 11th. And we are always on the lookout for volunteers. So if you want, you can message myself or Abdullah through Meetup, and we will more than happy to work with you. So it's 2 days for the conference. You work an 8-hour day, and then you get a free day to yourself.
And you get a
you would get the
you get a free ticket out of it. That's kind of the important part. Tickets are not super cheap, so you put in volunteer time, whether that's with the training or with the actual conference, and part of the ticket. And you also probably get a cool volunteer T-shirt.
Yep.
That's
how we get.
It's all about the swag.
That's what's important.
I'm still jealous of that shirt. I never got one.
Yeah, it was your idea.
It was my idea on that shirt. I love that shirt.
And in 2016, all the leaders got
Exactly.
all right. Yeah.
Yeah. So I'll hand it off to Rich for DevSecOps. So thank you.
Pretty sure I just plugged my hardware. Oh, there it goes.
Cool.
Thanks, guys. So my name is Richard Mills, and today's talk is something I put together, which actually is a variant of a talk I submitted to Global AppSec. So we'll see if it gets accepted or not. So I expect awesome feedback from you guys. Now, anyway, I'm very open to feedback. So if anybody has any ideas on this talk, by all means, let me know. But I want to talk about today what I call essential tooling to enable continuous security. It was an interesting overlap. She mentioned about DCAST and the fact that agile testing now, like one of the big things I think we're trying to do is drive the industry towards things like continuous testing, right? Continuous everything. We're trying to do continuous delivery, continuous integration, continuous security is kind of a big thing that's starting to crest, if you will. So a little bit about myself. Who am I? Why am I here? Again, as I said, my name is Richard Mills. I started my career as a software developer. So, you know, a long time ago, once before they had computers. I was doing a lot of C and C++ development, got into a lot of the aspect of building tools and into the whole software process concept, which is, I was really interested in making the job of a programmer easier. to allow us to basically build better software faster. Throughout my career, that kind of went into product architecture. It went into a lot of CM. It went into a lot of quality assessment. And one of the things I always learned was, wow, I really don't like testing. How do I automate this so that I don't have to test anything anymore, right? And as it evolved, we got into this whole application security space, and the application security space itself started to expand. And we realized, well, application security is really just a subset of application quality, or vice versa. I'm not sure which, but you can't go one without the other. So I spent a lot of time in the security world, did a lot of training courses, worked for a company called Cigital, which eventually got bought by Synopsys, where we built a lot of this kind of concept around how do you build software and how do you build it better, right? And I was always focused on the automation aspect of it, of trying to make it easier for all of us to do this, right? So it kind of got into a world of CI, continuous integration, continuous delivery, eventually DevOps, timeout.
Sorry, that's why we don't like you.
Is it not sharing anymore?
No, it is, but it is sharing.
Oh, it's on the wrong screen.
Yeah, it's on the wrong screen.
Yeah, that's what happens when you unplug. Okay, hold on. Let me go find the meeting. Thank you.
No worries.
Yeah.
You're an excellent presenter, by the way.
Oh, thank you.
Your content was great.
That's all I needed. Where did it go? Come back.
Of course,
where's the
on the
meeting?
day we have to leave. I feel like this is
Exactly.
Reston really telling us, go.
Just get out.
Go to Tyson.
Okay.
It's actually been the whole
Da,
building,
da,
like,
da,
the last
been
couple
all
of
day,
days.
That
actually.
one. Is it better, Gene?
Started failing, like, really weird.
There it is.
Whoa.
There it is. Thank you. Okay, the good news is there wasn't any good screen content yet. Anyway, so one of the things I found is they kept inventing new words for what I do. They invented the word DevOps that seemed to be describing what I was doing. You know, eventually they invented other words like DevSecOps. And if you've ever heard one of Nathan Harvey's talks where he makes fun of the term DevSecOps, we've always considered security to be part of what we were doing in DevOps, right? It's just part of how you build software. So apparently now I'm a DevSec QA Enterprise BizOps specialist. Congratulations, me. But anyway, so right now I work for a company called Coveros, and how I make my living is working with customers trying to set DevOps pipelines in place. You know, as a company, we do a lot with Agile and Agile transformations and development. You can read about our company somewhere else. But a lot of this stuff that I talk about in these talks is stuff that I've done with customers. A lot of what I'm going to talk about today is actually going to be my experience setting up a continuous security pipeline for a customer over the last 18 months. Right, so that's where all this stuff comes from. And sometimes we play around. We have a little product that we've thrown out at security called Secure CI, which is really just an open source assembly of, if you don't know where to start with setting up a CI/CD pipeline, go launch an Amazon image and it has a bunch of stuff in it. But it keeps us, again, it's about tooling. It's about how to make life easier. So what it comes down to is, why am I here today? When Gene and Ben and a few others asked me to come talk, I thought I'd come and share some of my experiences, maybe a little wisdom, that's useful to people who may be struggling with trying to incorporate security assessment and incorporate application security into the actual application development process instead of trying to bolt it on the end and being very late in life cycle. So I'll share a little bit of my experiences, you know, both successes and failures, some of them painful. And talk about what we try to do to create something we want to call continuous security so that we always know that our software is secure, right? I'll give you a little bit of visualization of kind of what some of these pipelines look like. I like pictures, so I try to do a lot with pictures and try to kind of give you an impression of what this really means, of how to build this thing called a pipeline and put this stuff called security in it, right? So I'll talk specifically about some categories of tools that, if you are trying to do continuous security, if you are trying to do DevSecOps, and you are trying to deliver secure software, where do you start? Which tools do you pick first to try to run it, put in place, right? And I'll give you a little bit of anticipation of some of the challenges of why that's hard, or the pitfalls you may fall into as you go, right? So, and one of the key things, and we'll talk about this, is this last bullet point, which is, if security is always viewed as police of the bad guys that just keep telling me no, which is, no, you can't ship your software, no, you're doing it wrong, this is bad, you're insecure, it becomes more and more difficult. So what do we do to try to integrate those into what we go? So, and I'll try to give you a little bit of some kind of reference point to walk away with. So, agenda-wise, what I'll do is I'll go through and I'll talk a little bit about, the rapid development of modern DevOps kind of thing versus the often slow security processes. I'll talk about some of the, I'll give you guys an example of kind of what I'm framing this around very quickly. We'll talk about a little bit about what we mean by DevOps and what a pipeline really is and how security and/or everything else fits into it. Some important tool categories, and then ultimately, how are you going to take all this data and all this tool results you're going to get and do something useful with it? So that ultimately what we can do is integrate teams. Before I get started, quick survey in the room. How many people here, I know we got two different groups of people, how many are in the information security or the application security space, if you will? Somewhere at least half. How many people are in the kind of agile testing and other space? Somewhere lightly than half. How many didn't raise your hand before? Excellent. It's always good to see as far as kind of what the mix is. And it is a good mix because one of the things we'll find is that this is actually a very good kind of overlap topic. One of the big parts of the problem to me is that as we're going in this agile software development world, right, where what we're doing is we're pushing software faster and faster, right? Agile is about producing incremental software and software that always works. And DevOps to me is an enabler of that, right? When we talk about DevOps, we often focus on, oh, there's lots of automation about it, and it's bringing teams together, and it's bringing, automation into operations. So instead of just building continuous integration or building, simple automation and test automation, it's bigger than that now. We're deploying software, we're pushing it through environments, right? So the whole point about DevOps is to deliver value quickly. And that's very important. So we're trying to push stuff quickly, right? Well, often I've gone into many organizations where the security teams are this disjoint, strange group that works down the hall on a different floor somewhere. And we are required, before we ship a piece of software, to sit down with them and have this horrible word called an audit, right? Or maybe I have to ship my code off to them once in a while, and they're going to run a Fortify scan on it, and they're going to send back a results file with 100,000 elements in it and tell me to go fix my stuff because I'm an idiot and I did it all wrong, right? So you're working with a culture where a lot of times the security people are these just mystical naysayers that we don't want, right? And what we find is as we try to advance our software, we don't have time for this slow, manual, late lifecycle security, right? A lot of the AppSec professionals have been trying to push security earlier in the lifecycle for years and years and years, and of varying levels of success. I'd love to say I've been in lots of places where it's all working great. There aren't that many. I've seen some. I've been in some. We learn over time, right? What we really want is we want to know that our software is secure enough every single day that if we had to ship it, we could, right? Which means I need some way to have confidence on a regular basis every day that the software can defend itself, right? That we've put it together, that we've done the right things, we have the right controls, we have the right protection, we've configured it properly, we don't have, rampant OWASP top 10 problems buried in our software somewhere. Right? So what we need, quite frankly, is this continuous security assessment. And that's kind of where I'm going with this, is that's what we need. So what does that look like? Well, the magic answer to the problem is whatever we're calling this DevSecOps things, right? Because it has the word sec in it, and it has DevOps, so therefore it must be better. To me, DevSecOps is just the good thing about the term DevSecOps is it's adding awareness and importance, if you will, to a lot of the things that a lot of AppSec professionals have been trying to push for a very long time, right? So what we're trying to do is, of course, shift security left. And of course, what that means is do it earlier, right? Left-hand side of the life cycle in the timeline is you want to do it as early as you can. In the agile world, what you're really trying to do is figure out how to put security assessment and security process into your daily process, or maybe your sprintly process, right? If you're working on an agile team and you're doing a lot of definition of stories, how many of those stories have a definition of done associated with them that says, oh, well, based on this feature addition we're doing, let's go do a little threat analysis and a little security impact. Like, does this have any security impact? Is it dealing with sensitive data? Is it going to change the software in any way? Does it require firewall changes when we design and implement it, right? So, it's the kind of thing where what we really want to do is wrap into our, weekly sprint process or biweekly or whatever you're doing, ways to think about security as early as you can, So that you're then going, oh, well, what are the security requirements about this? Oh, well, maybe when we do that, we should also build some security tests for it, or maybe we should look at it, or maybe we should scan the code. The point is your definition of done has to include all of those little bits of security analysis that people so often want to push off all the way to the end of the process, right? So that's what we're trying to do with DevSecOps and continuous security, right? And what this really means is we need to get to a point where we're putting touch points into our CI/CD pipeline, into our automation process, into whatever it is that we do to build and deliver our code through our value stream. So we need to inject those things, right? And a lot of times what it does is these touch points are opportunities to start running these security tools, right? Some of them are processes, but a lot of what we've learned with security tools is their codification of security knowledge that we've built over time, right? We have the CVE and the NVD and the databases full of all kinds of known broken things out there, right? We have scanners like Fortify or like any of the open source scanners that are codified knowledge of mistakes people have made in the past that we don't want to put in our code again, right? So we have tools, and a lot of times it helps us with this. And what it does is it accelerates and it takes the mundane stuff out of what we do on a daily basis and repeats it, allowing us security professionals to spread our skills a little better and actually think hard about the actual hard problems that are left, right? So we want to use tools, right? And there's things like static analysis and dynamic testing, composition analysis of third-party components, actual scanning of our platforms and our operating systems and things like this, right? So I'm going to talk a little bit about what some of these tools are and how they fit into a pipeline, right? Because what we want to do is we want to have these touch points in our sprint cycles using these tools, and when something is not compliant, when it is broken, when it has vulnerabilities in it, we want to break it, stop it, and say, don't go any farther until you fix it, right? Otherwise, you're building technical security debt, and let's face it, you're never going to get to it because you don't, right? So that's what we're trying to do with DevSecOps, and we're trying to build the right people working together to be able to do that. So that's where we're going. So just to set a little context, I'm going to talk a lot about things I've done in the last year and a half. And let me give you an example of what I was doing it on. So this is, to some extent, you don't care, but it'll add a little framework to it. For the last year and a half, I've been working on a project, which was, oh God, that formatted horribly. Basically, it was a re-implementation, a greenfield re-implementation of existing registration system for the government, right? And in the end, what we did is we built a, basically had a couple dozen independent kind of running services, microservice. It was very buzzword compliant. We had microservices, and we had Docker containers, and we had OpenShift Kubernetes. We had all this fun stuff, right? Very buzzword compliant, very modern architecture. But as part of this, what we were doing is we had very strict security requirements. Like there were compliance requirements and all kinds of stuff that they wanted us to do to make sure we were producing continuously good software, right? So we took that and we figured out what we're going to do with it. And the way this thing was, so this, bunch of Java services and JavaScript services, it gets deployed into an environment, which, just for reference, again, it was all hosted in Amazon. So somewhere at the bottom of this technological stack, we had Amazon EC2 virtual machines running stuff. On top of that, we were running a system called OpenShift Kubernetes distribution. It's basically just a way to run a lot of Docker containers. How many people are doing containerized stuff nowadays in some capacity? Okay, so meaning the other half of you aren't. And that's fine. So anyway, so we run this OpenShift cluster, and then on top of that, all of the services that we were building out of this system were basically just Docker containers that were virtual servers. For those people who don't understand Docker, it's basically just like a bunch of virtual servers that have worked together and they do stuff, right? It's a typical application framework. It's also the same platform that we ran all of our pipeline tools. So all of the Jenkins and the SonarQube and the stuff I'm going to talk about today was basically running this environment as well. Why is that relevant? I don't know. It sets some context, but that's kind of what we were doing. The other interesting thing, this is kind of relevant in many ways, we had what we call our DevOps cluster, right? And when you start talking about DevOps and you start talking about automation and pipelines, you very frequently have something in control of everything, right? So my pipeline that I'm going to talk about today runs in this kind of space up here, and all the tools were up there, and it was in charge of of controlling the rest of the application clusters, so that I had a development cluster and a staging cluster and a product cluster, and these are basically my test environments, right? So all that stuff is available, and it runs and it controls across multiple environments. So as I'm pushing code, right, as developers are developing code, I'm going to push it into one environment. I'm going to do a bunch of assessment. Assuming it's good, I might push it to another environment. Eventually, it goes towards prod and finishes, right? And I'll talk more about what that is, but that's the general context. Bunch of services, lots of them running together, lots of things changing at once. One of the things that you observe out of this is, if I back up a couple slides, all of these are basically independently deployable applications, right? So I had, 24 different code bases at any given time that developers were throwing code into, checking in code, and running out into an environment somewhere, right? This is an environment.
Would you say that's microservices?
Yes, it's absolutely a microservices architecture. And the whole idea is, theoretically, in the microservices world, if you do it right, these things are very independent of each other and can change independently, and you can isolate them, and that's all fine and good. It's a lot easier said than done. What you tend to create is, by creating that isolation, you have this huge release management and configuration management, which is, okay, if this one is changing faster than this one and they depend on each other because they make calls to each other, how do you know they work together? How do you know they don't break the quality of it? How do you know? And the answer is, you have to test the crap out of these things, right? The same is true with security. With this stuff advancing so rapidly in so many ways, it's no longer one monolithic app that you just give to somebody once in a while and say, go do a big audit on it, right? It doesn't happen. It doesn't work. You can't do that anymore. Without a high level of automation, somebody told me once, it's like, if you're doing microservices and you don't already have a highly automated CI/CD process, you've already lost, right? And it's very true. Stuff moves so fast, you can't keep up with it, right? Security is the same way. If you just have some security team down a hall that's going to, pick this one to look at this week and this one to look at the next week, it's going to be 3 months before you get back to it in the rotation. It doesn't work that way anymore. So what does that mean? How does this translate into what I will call DevOps in the modern pipeline, right? So this is an example of a hypothetical but very real pipeline, right? And when I talk about a DevOps pipeline, what I mean is it's basically the software delivery process. I even wrote it down. I would remember. But it's the delivery process that your software goes through to get from effectively a piece of code that's going into a version control system into a running environment somewhere, right? And in general, we mean test environments, production environments, right? So it's the set of steps it goes through. And many times, sometimes we do this thing we call value stream analysis. It's like, what different groups, what different steps, what different things have to happen to this piece of software in order to get it there? Well, when we talk about continuous integration, continuous deployment, et cetera, there's typically 3 phases that become relevant, right? There's continuous integration, continuous delivery in the middle, and then finally, what I'll call continuous monitoring on the right. And in the continuous integration phase, it's at the beginning of your software, somebody checks in a piece of software, and somehow you have to build this thing into a runnable piece of software, right? So there's a lot of compilation and testing and publishing of packages that are actually runnable, right? And while you do that, there's actually a bunch of assessments that can happen underneath it, right? We do things like unit testing. We do stuff like we measure code coverage. And we start to talk about things that we can do with security, right? We can start running OWASP dependency check tools. And I'm going to talk more about what these tool categories are shortly. But we do a lot of things. And ideally, what we're trying to figure out is the software good enough that it's worth installing somewhere and testing, right? There are things that we can do from quality that I'm going to talk about, and there's things we can do from security, because we effectively want to figure out, are we doing enough testing? Are there bugs in there? Are there vulnerabilities? Are we amassing technical debt? And I want to find these things as early as I can so that this piece of installable software I know is worth taking further. The next phase is typically what we call continuous delivery. And at the continuous delivery standpoint, what you're trying to do is you're trying to take a piece of software, get it running somewhere, and verify that it's good, right? You want to get it in front of the users who need to see it next, right? So this is the phase where we typically figure out what servers we're going to provision this thing onto. We install our software, we configure it so it works together. And again, When you've got 20 some odd services, you need to install all 20 of them perhaps and wire them all together so they talk to each other and they talk to the right databases, et cetera, so that we can move on to a testing phase where we actually execute some kind of tests against it. Lots and lots of different kinds of those. And then finally, if that's good, we may consider promoting it to another environment or to another stage of testing, right? So we go through these cycles. And again, somewhere along this, we can do things like vulnerability scanning. We can run more tools against it. We'll have some manual testing. We'll have some functional testing. We'll have lots and lots of stuff that we can do, and more tools that we can run against it. Assuming that all works, I may promote it from a staging environment, can't remember the words, but oh well, staging environment to some kind of pre-production environment and eventually to production. But the point is the last stage is kind of this continuous monitoring. And when we talk about continuous monitoring, I now have a running piece of software. I want to keep it running. Right? So a lot of times I need to figure out ways to monitor that that is running properly, that it's maintaining performance, that it's doing what it's supposed to do, it's functional, that it's not being hacked, that it doesn't have security problems, et cetera, right? So there's a lot of things, again, I can do over there to detect when things are going badly, and oh, by the way, provide feedback, predict when things might go wrong, and try to fix those things, right? So this is all things that we can do throughout our CI, CD, and frankly, continuous monitoring phase. So one of the questions I have for you guys, how many people here have something that they would refer to as a CI pipeline or a DevOps pipeline? Show of hands. Pretty decent set. How many people here exist in largely a manual world where Joey builds the software and puts it in an environment somewhere? How many didn't raise their hands? Excellent. Good. I think that's most of them. Okay. So a lot of us are starting to see this, right? This is becoming more popular. That people this is the way to do business right now. If you don't have a Jenkins server or a Bamboo server or a Circle CI server that's doing your build somewhere, you're being left behind fast. Go talk to somebody and fix that problem, right? Most people now at least have continuous builds or nightly builds or automated builds somewhere, right? The days of the config manager release engineer guy, Timmy, being the guy that builds it on his laptop and then uploads a zip file are rapidly going away. And if you're still living there, you're a dinosaur and come talk to me and we'll see if we can help you fix that problem. So, but throughout these kind of pipeline stages, what you really want is you want this pipeline, this set of tools, these things that are being done to provide you as much feedback as possible, right? So as we move from requirements to code to check-in, unit tests, et cetera, deployment to staging, pre-prod, eventually production, there's these kind of octagon things in there. Oh, they're not octagons, they only have 6 sides. Oh, I don't know what that's called. Anyway, but the point is there's these typically these things that we refer to as quality gates in there. And their job is to detect or to assess the level of quality of security of everything of the software at this point and decide, is it allowed to go further, right? So not only are we pushing forward through this kind of pipeline, we want to be providing feedback at all times so that I know when I have to kick it back and fix something or repair something or do something, right? There are other subtle benefits, not subtle, very specific benefits of automation is the repeatability of things, which is the more you automate, the more often you do things, the more confident that you are. By the time you get down to the bottom level, you're pretty good. You're pretty sure you've practiced this enough times. You're pretty good and pretty confident at driving it. So that's the idea behind these pipelines. We want them to be able to provide feedback. So back to that kind of original stack that I showed you guys, right? Somewhere we've got like running virtual machines on the bottom, right? And then we've got a bunch of middleware and other crazy software installed somewhere. And then we've got these pods and these Docker containers that run on top that have even more middleware and different levels of stuff built into them, right? So by the time I get to a single line of my microservice code, I've got thousands or millions of lines of code running underneath me. Lots of things that could go wrong, right? So one of the things that we try to do is have different levels of what I call platform assurance, with this whole technical stack assurance wrapped into what I'm doing continuously, right? We know at the top the application code needs to be scanned and assessed to make sure that we're not writing bad code, right? We know that these Docker containers that we're going to build, which again are they're virtual servers, right? They're an assemblage of a set of software that runs as a little virtual server somewhere. We need to make sure that that software we've assembled into there, we've done correctly and doesn't have flaws and it doesn't have vulnerabilities, doesn't have known problems, right? Underneath that, let's say this OpenShift cluster, again, a big fat body of software with middleware in it that needs to be configured and hardened for security because it's my operating environment. I want to have things like firewalls and all kinds of wonderful security terms around it, right? The instances underneath from Amazon have to be configured properly. They have to be hardened, right? These are all things that need to be assessed on a regular basis, right? And then ultimately, this entire stack needs to be monitored to make sure that it stays together and that it stays functioning properly, right? And I've slathered on, again, a lot more tools, right? These are a lot of tools that can help us do this because if you have a human that's going around and trying to look at all these things, the guy's going to, die many, many years before he ever gets done trying to look at all that. So we have different levels of this assurance, and we need tools to help us there. So what do these touch points look like? Yeah, go ahead.
So, what about like security between touch points of the tools themselves? So, like, Jenkins needs to talk to you, for example, or Docker needs to talk to the registry, stuff like that. Like, what about security among?
Yeah. So the question for anybody in the other room to repeat is, what about security of the tooling, right? And I usually refer to it at two different levels. And the one you asked, I'm not going to talk a lot about today. But it's basically security in your pipeline, if you will, which is how do you guarantee that you're producing secure code, right? And that's a lot about what I'm talking about today, which is how do you get the right tools in your pipeline and in your process so that you're producing secure code. The other thing is, quite frankly, securing your pipeline, right? Which is a lot of the questions you just asked about, which is, okay, you've got Jenkins and you've got, I don't know, Chef and Ansible, and you've got Kubernetes, you got all these tools that have superpowers over all of your environments, right? Because I said, in the diagram that I showed, there was kind of at the top, there was the DevOps cluster, right? And then there were the app clusters underneath it, right? And a lot of times that DevOps cluster has all the superpowers it would ever need to do both good and bad things to your application. And you need to be very concerned with how you secure that, right? I've seen many places where, secure, like your Jenkins server is wide open and it has the ability to deploy to prod, right? So now basically anybody on your app team that gets access to your Jenkins server can deploy new code to prod. Well, in a world like Google where you've got lots and lots of great assurances that anybody can deploy to prod at any time because you have so many automated processes, that's fantastic. But that's a very secure pipeline. The point you raise is very valid, which is there are techniques that we typically refer to as DevOps engineering, which is how to engineer your pipeline so that the pipeline can protect itself. So that when you have bad agents, when you guys are the developers and the database guys and my entire development team and my ops team, how do I protect against you guys when you guys have access to the tools? So it's a good question. I don't talk about it in this tool, but it is very important, or in this talk rather, but it is a very important point. I'd be more than happy to talk about you separately. So, any more questions yet? So touch points. When I talk about security touch points, I talk about, okay, where in this whole process, in this pipeline, should we be thinking and doing things about security, right? And this is your, what I will now call the classic infinity diagram of continuous delivery. In that there's a lot of very important phases, right? So if we want to start at, let's say, the planning phase here, it kind of goes around clockwise in this infinite circle, or infinite figure eight, I guess, right? So at some point you're doing planning, coding, building, and testing, right? This is your typical development cycle where you're building out code, right? And as you do that, we can wrap this thing in security, right? Where as we're planning, we can start with requirements analysis and threat analysis and say, okay, well, based on these changes, what's the security impact, right? I kind of mentioned that earlier. What's the security impact? What could go wrong? What kind of sensitive data am I dealing with? What requirements are being held against? What are my compliance requirements? I can start thinking about what I'm actually going to need to do to secure my code as I move forward, right? At some point, we start looking at secure code review as people start coding, and static analysis, where now I'm just concretely looking at the code, haven't run it yet, but I can examine the code and I can start looking at it. Are we designing it properly? Are we using secure coding practices? Do we have the right standards in place, right? Are we doing the things that we need to do to make sure we're writing good code, right? As we start moving around to where we're building it and testing it, I can use, along with static analysis. SAST is basically static analysis security testing. It uses the word testing. It really, what they're doing is they're testing and examining the code for those things I just talked about. Right? Are you following coding standards, common security problems? Did I just put a SQL injection vulnerability in my code, right? So we have the opportunity to do that stuff here. SCA, in this case, who knows what SCA stands for? It's a trick question. It stands for like 30 different things. In this case, it actually means software composition analysis, not secure code analysis, not security control assessment, whatever. It means so many things, you're never allowed to use the initial SCA again. Anyway, in this case, we're talking about composition analysis. We can start looking at what components are we pulling from the internet, what third-party components, right? And I'll talk about that in a few minutes. As you come around, we can use dynamic security testing. Where we're executing it. We're doing pen testing. We're running different tools against it. Interactive application security testing, which actually is plugged into the running software and monitoring what's going on, right? So we can do a lot of things to actually test it. Penetration testing. As we cross over and the software is released, this is where we start looking at our infrastructure, right? Where we're doing vulnerability scanning. We're looking at things that we might have done wrong with our infrastructure. We're making sure we're using good controls out there like encryption. And then finally getting around to actually monitoring it. Some of the new RASP is, what does RASP mean? I can't remember. That's it, runtime application security protection, where it's actually intercepting and blocking things, right? And then eventually security event monitoring. Never mind, give me a minute. No, there are, and you're absolutely correct, there are 1,000 other things that I can put on this. Because WAFs protect everything. Absolutely. We all know that. So anyway, the point is there's many, many things throughout this entire channel that you can do that contribute. Are we all going to do all of them all the time? Probably not, but you got to start somewhere, right? And some of these I'm going to actually jump into and talk about. The point is I want to pull it back to these whole things where I call them quality gates, right? We talk about them as quality gates or security and quality gates. From a pipeline perspective, what I'm looking for are things that I can put in this delivery pipeline that I can call a quality gate, which is a blocking point of assessment that is you either pass or you fail here, right? And by the way, when I say quality, I mean quality and security and maintainability and every other ility you can think of, right? I'm using quality as a very generic word to include all of the important aspects that we want our software to exhibit that are non-functional definitions of what we're trying to do, right? So the goals when we build these, quote, quality gates is that we're ultimately trying to provide an overall picture of health of our application. And by health, I mean security, et cetera, et cetera. Ultimately, we are trying to stop bad code from making it through our pipeline, right? If it's bad, it means you've introduced something that wasn't bad yesterday, which means you broke it, go fix it. Ben, you're a bad person, go fix your code, right? And you want to be able to catch these things as early as you can because they're a lot easier to fix if you just introduced it. We want to enforce the standards that we have and basically ensure code is production ready at all times, right? And at all times and production ready are certainly a little bit gray when you want to define, but the more gray it is, the harder it is to follow and the more likely it is you're going to do it wrong, right? Ideally, all of these quality gates, we want to be automated with tools in some way. You're always going to have some aspects of manual stuff in there. You want that to be off to the side if you can, right? And you want to minimize those. Which brings us to tools. Oh my God, there's a lot of tools out there, right? You can't see it because of the sharing thing, but Zebia Labs actually puts out this cool little periodic table of security tools out there. I don't care what's on this table. The point is, it's got what, 50, 70 different tools on there that list all kinds of stuff you can do with quality and security, et cetera, et cetera, et cetera. There are way too many tools. There's lots of tools. If you can't find a tool to do what you want, you're not looking hard enough, right? There are a lot of really good tools out there. In many cases, there's a lot of free tools out there. I highly recommend, if you don't know where to start with free tools. They will help you learn what you need to know about tools what works well, what doesn't work well, how to actually then go, oh yeah, now I understand why paying money for a tool actually helps me, right? So you can learn a lot by just trying tools, right? Anybody who's ever used, open source free tools eventually figures out that, oh yeah, all those enterprise reporting features for assembling many things together, yeah, I waste a lot of time trying to build those reports. Maybe I'll pay money for a tool like that, right? You eventually learn. Start with free tools, you'll figure it out. So back to the key kind of point of my whole talk here. What are some of the essential things that you need? Did you have a question?
Yeah, are you gonna talk more about the gating the later part of the slide?
I mean, a little bit. What do you have in mind? What's your question about gating?
Like hard gating versus soft gating, SLA for the gate. Like if you're gating something, your scanners and all the tools
Right.
should be a certain SLA, right? That should go in sync with your delivery pipeline. If NAB needs to go.
Yeah. So to repeat the question is, it's about hard gates versus soft gates. SLA is really how long they take and how much time you have available to produce. I'm not going to talk about that heavily, but what I'll hint at a couple things right now, which is, you said a couple things, hard gates versus soft gates, right? Ideally, you want a breaking gate, which is, it's binary, and I do have a slide later on, which is it either passes or it fails, right? It doesn't require somebody to go look at a log to figure it out. And it may involve thresholds, which is if X is above 17, then you fail sort of thing. But you want that kind of hard gate, if you will, which is because then it actually breaks and it forces action. If it's, I don't know if I'd call it a soft gate, but if all it does is you run a tool and it produces a log somewhere and somebody will eventually go look at it, what will happen is nobody will ever go look at it and it will never generate action because people are too busy doing other more important things because it is broken and it is on fire. So my general advice is try to force hard gates when you will. My last project, we started with soft gates, which is we got all the frameworks in play, we're running all the analysis, and we spit it all out, and we said, you have 37 problems, go fix it. And they said, no, I'm too busy, I can't fix it, come back later. Which means I had to leave that gate effectively disabled, and then it went from 37 to 50 to 78 to 150 because there was no teeth, right? There was no chewing on it to say, no, you can't go any farther unless you fix that. Everybody was always too busy, too many priorities, right? So ideally, you want to get that to kind of go. And I'll talk about that at the end. The SLAs is an interesting one. When I think SLAs, I'm like, okay, if your pipeline takes 3 hours to run, people aren't going to wait around for it to finish. A lot of times for like a CI, you have between 5 and 15 minutes to be able to produce a valid build. And if you're running enough tools in there that it's taking longer than that, then developers are just going to check in his code, let it run, and he's going to go home for the day, right? And maybe he'll find it tomorrow morning and fix it. Meanwhile, everybody else is busted because he's gone. So you definitely have to look at it. There are things where some of these gates and some of these tools you will want to think about, can I do something quickly here to catch most of the problems and then run a nightly in-depth scan to do something bigger, right? So when you start blowing your SLAs, if you will, you start trying to streamline what you're doing with some of these tools to make them run faster and quicker, lighter fidelity, and then go, okay, now I'm going to run a full-blown performance test sometime overnight. And I got 8 hours to run. I can do whatever I want, right? So you do start thinking about that as you start introducing tools. Does that answer your question? Good. Okay. Any other questions? I will start talking really fast again, like I always do. So 3 or 4 major categories of tools that come down to what I would consider to be very essential when you're starting to think about orchestrating a DevSecOps pipeline, right? The first one is static scanning, right, or static application scanning. And this is where you don't have to really run your application, but instead you're analyzing the source code. You're looking at the application structure. You're looking at the platform it's built upon to detect defects and vulnerabilities, right? And this is where, I'll talk about scanning tools like code scanning and whatnot. I'll get into that in a couple minutes. In the security space, this is often what we refer to as SAST, static application security testing. Software composition analysis fits into here, and vulnerability scanning all fit in here. I'll talk about those in a few minutes, right? Somewhere in the middle here, I've grayed out what I will call dynamic functional testing. Functional testing is where you prove that your software does what you intend it to do, including the doesn't break kind of stuff, right? Positive, negative testing. But it's really about verifying things against functional requirements. I kind of grayed it out because it's relevant, because a lot of what we're doing is mirroring that. But in reality, when you talk about it's functional testing. Security is by nature kind of usually a non-functional thing. The reality is there are also functional security requirements. You have your authentication system, your logging, your auditing and stuff. So you can test against that. But quite frankly, to me, that's the easy stuff. Why? Because there's functional requirements. And if I see a functional requirement, I can write a test to match it, right? And that fits very normally into your testing process, right? And it's just writing different functional tests to test different pieces of your functionality, right? But what I want to focus on is eventually you get past the functional testing and you get to what we frequently call the non-functional testing, right? And this is where you're verifying the software against a whole bunch of subcategories, again, that tend to be cross-cutting and by definition, non-functional requirements. These are your security, performance, accessibility, et cetera, et cetera. This is typically where we get into the dynamic application security testing and a few others. So I'll talk about those in a few minutes. And then, at this point, you've kind of assessed the security of your software. And now we use real-time monitoring and make sure that it stays secure, right? Because one of the things that we find over time is just because it was secure today, even though I changed nothing, it may not be secure tomorrow, right? We're continuously discovering new things, other things break, stuff changes underneath us, right? So while this isn't necessarily a security gate, it does ensure that the software remains healthy, right? And there's more tools and more processes that come into these that I'll mention in a few minutes. So static application scanning. This is really, to me, this is anything you do that you can analyze the assets of the system without actually running your application, right? So you have static code analysis, right? These are where you can look at quality, maintainability, security, right? That's what we care about. And this is typically what we refer to as SAST, where you're looking at the code to figure out, is there anything that I've written as well? I'll show you an example. Software composition analysis. I've mentioned this a couple times, but this is where you start looking at, well, all those third-party components I'm pulling off the internet are getting from various problems. Are there any problems with those? Am I using, Bouncy Castle 1.2.3 that has known bad things in it when I should be using Bouncy Castle 4.8, which is only 20 years old instead of 50 years old? So this is where we start looking at how we're pulling and assembling our components together. We look at platform vulnerability scanning, where this is stuff we've been doing for years and years, where whether you have a physical piece of hardware or a virtual machine or, quite frankly, even a container, I'll talk about in a minute, where you're scanning that to figure out, am I using healthy versions of the operating system? Have I, configured things properly? Have I locked down firewall ports? Am I looking at the rest of my network infrastructure? But this is where you're looking at the middleware and your infrastructure and whether you've wired it together properly before you put in your own software on top of it. The same is now true with Docker containers. A Docker container, for anybody who doesn't know, is built basically an image, which is an assembled set of software, just as if you had a virtual machine with an operating system and stuff installed on top of it. That, again, pulls in packages, right? And these are third-party middleware, different software components, and there's ways to get those wrong. The good thing is, because this thing is a thing you build out of your pipeline, it's something you can look at. Before you ever put it anywhere and run it, you can look at the structure of what's in it, what's installed in this machine, what's it going to do, how's it configured. So there are now container scanning tools that allow us to look at things there. And there's lots and lots of tools out here that I'll talk about. A bunch of static analysis tools, dependency check. I'm actually going to get to these in a few minutes, so I'll just move past that. So when we talk about static application security, there's a lot of stuff. So question for you guys. How many people are using static code scanners? Lots. What are you guys using? Fortify? Checkmark, Faircode, FindSec,
open source side.
SonarQube, FindSec modes. So, okay, good. Yep. So lots of them out there, right? And there are a lot of tools out there, so I'll talk about that. One of them, if you have none and you don't know where to start, and this is what I tell people everywhere, if you're not doing static analysis, go download SonarQube, boot the server, and start running it immediately. It is the easiest thing in the world to do. It has find bugs built into it, which now includes FindSec bugs. Like, it is a standard out of the thing. And arguably, it's open source. And you can get in a nice big argument with people about how good those rules are, but they are way better than nothing, right? And they will find basic problems, right? And if you're doing nothing, this is the place to start, right? again, you will learn. Oh, well, gee, it's not really finding all of these problems I want, or it's not great. It's not the best in the world. Fine. Learn how to manage it, and then go out and figure out if you want to spend money on Fortify or any of the other big products out there. You know, Fortify is a very, very detailed product. It has great fidelity. It digs way deeper in code than something like SonarQube can, but at least start somewhere, right? And SonarQube will do it, right? And it gives you nice little indications of like A's, B's, and C's grades. It's very easy from a dashboarding standpoint to see where your health lies and to dive down into it, so you eventually end up on a page like the top right that says, hey, you're using a bad random number generator. This is stupid. Don't do this, right? And it's easy for developers to see. It's easy for them to fix. If you have no other tools in your pipeline to do security, start here. It's very easy, right? And there's a lot of inexpensive alternatives to doing this well. Second one, dependency checking, right? He laughs. I'm the yeah, I know. What a piece of crap.
It is.
No. So the whole idea between dependency checks, I've mentioned this and I've kind of beat it up already, which is you're pulling down components from the internet. You know, everything from Spring Boot to Bouncy Castle to whatever. Thousands and thousands of components. A lot of those are already known to have problems with them. This basically just looks at your dependency tree, compares it against a database, and says, don't use this one, right? And that's what OWASP dependency check does, right? It's really just comparing a list of stuff. It's not all that complicated. I say this because I don't write the product. It's not that complicated of analysis. There's lots of other problems that go around with it. And it just does it, right? And there's versions for Java. There's JavaScript stuff. We use retire.js for JavaScript, which I think OWASP can use, although I've never made it work. And it's a pretty simple check to go out and do it. And it pulls all this stuff together. There's also commercial implementations of repositories. How many people in this room use Nexus? Artifactory, right? They're artifact stores. Both the commercial products have, you know, Sonatype has Lifecycle with its IQ server. X-Ray JFrog Artifactory has X-Ray, and these basically do the exact same thing, which is as they pull components from the internet, they study them, compare them against it, and say you're doing something bad. Like, this is a bad version of a component, go get a better one, right? And the point is you can tie this directly into your pipeline so that at a certain phase, and I'll show you where it ties in, you run the check and it says, oh, yeah, I either newly discovered that this version you were using is bad, or you're using it and it's bad, don't use it. And it provides advice on how to fix it, right? Very powerful, not that hard to set up. One of the things I will warn is that the more tools, and this is where it starts to build up a little wisdom, the more tools you start tying in your pipeline, the more results you have in more fragmented places throughout your pipeline. Sometimes it's hard to figure out where those results are. If you use a product like retire.js, it spits out this wonderfully hideous text file that's basically illegible, but at least it says that there's stuff wrong with it, right? And this is where the learning process comes in of, oh my God, these results are horrible. How do I translate it into something useful? I'll talk a little bit about that at the end as well. We've used Hygeia, which is a dashboarding product, to help us a little bit with that at times. Container scanning, right? So one of the things I said is we're putting together these containers now that are launchable virtual servers. Well, hey, this is another great opportunity to sit down and scan through it and look at whether we've done it right. So we can examine it, we can look at it. We used a commercial product on my last project called Twistlock, which is, I don't know, it's thousands of dollars, but it's not insanely expensive. There are free options out there, Falco, Cilium, Aqua, that I haven't used, but I've heard good things about. But the whole point is it actually fits two places in the pipeline. One is every time you build a new container, you can scan it and immediately find out if you've got bad stuff in it, right? So before you go launch it and waste all your time launching environments and configuring servers, you can use it to scan it. And so you can catch things pretty easily, and there's command line scanners to do it. The other thing you can do is Twistlock will plug in your runtime environments, and it's a monitoring tool as well, which is it will monitor the running containers and, again, rescan them to see whether anything new has been discovered about it. But it'll watch stuff like network traffic, it'll watch behavior of the container, it'll look at health of the container, it'll look at environment variables you're pumping into the container and whether it contains secrets. So it does all kinds of nice runtime monitoring as well when you launch it. So it's actually a very powerful tool, and there's a lot of competitors to these that are now starting to emerge. Where this kind of fits. So here's here's like different pipelines for my microservices. And if you look across the top, from the left, the first thing we do is we start pulling things together as we do our build. We pull our dependencies in, and then immediately I can run unit tests, but that's where I run my OWASP scan. So literally while I'm compiling my software, I can run these simple scans and figure out whether I'm pulling in bad components, right? At that point, I push along, I send it all off to CenterCube, and CenterCube looks at all the code, and it tells me I have SQL injection problems, and it rejects the code, and I go and I fix them, right? Assuming I pass that, I can now actually build, in this case, the whole parallel step in the middle is building my containers so I can run them. Once those are built, I actually, in parallel, kind of start firing off a new environment for it, but then I go and I do my container scan, right, to make sure that it's ready to go. And I kind of optimistically do that because it takes me a while to launch stuff, right? And then I move on and I do like real testing. And I replicate that, and all of my pipelines use the same code to invoke the same things, right? So I have this pipeline for many, many different versions of code, and it all basically does the same stuff. So I don't have to write a lot of really complicated pipelines in each of my repositories. I have one pipeline that takes in different repositories of code. Once we get past the static stuff, I've got systems that are now running, right? So now I have my application to do my dynamic functional testing. And this is where, the DCAST people love this. This is where we do all of our automated testing, right? Lots and lots of stuff. I got unit testing. I've got health checks where I can make sure things are running. My APIs and my UIs, I can automate that test. I can use, there's many, many products out there to do this. I'm not going to focus on it. But one of the interesting parts about the functional testing is these are good places where we can start thinking about, oh, well, if I'm doing functional testing here, maybe I should be doing my security testing as well. And one of the things I'll talk about in the next couple of slides is how you can start using security tools at the same time you're using some of your functional testing tools, right? Because once we start talking about non-functional testing, now we're starting to talk about proving stuff like my performance, does it run, how fast does it process, what kind of load can I handle, accessibility testing, lots of other compliance testing. But the primary thing we're trying to do is how can I start using security tools to do dynamic testing in my app, right? And a lot of times when we're talking about dynamic testing in security, we're talking about pen testing, we're talking about app scanning and web scanning and whatnot. There's a lot of tools out there, Zap, Burp, AppScan, Metasploit, Mmap, lots of things where we can start examining our running application. One of the ones I always like, and what I tell people to introduce, is if you don't have an app scanning tool, go get Zap, right? How many people in here, OWASP Zap, know about it? How many have actually used it? Good. Oh my God. The biggest group I've ever talked to. The fact that you're an OWASP meetup, though, I guess I should kind of question that. But anyway, right? So one of the things I like about Zap, or really any of these web proxy tools, we've done this with Burp, we've done it with a few others, is that it's got two main modes that you can use. And I don't know how many people have done both. I know Ben has because we've done it together. But you have what I will call the passive security monitoring, where you're using Zap, it's a proxy, attack proxy namesake, in kind of true proxy mode, where you've got these functional tests that you're running somewhere, and you basically just set up whatever the browser driver is so that it goes through Zap on its way, right? And in this case, Zap doesn't need to do anything, but it can observe the traffic, and it can actually learn a decent amount of stuff about whether you're doing just fundamentally wrong stuff in the way you've got your stuff wired and configured, right? And it spits out of the side, you get some security results out of it. This is what I call get it for free security results, right? Now, granted, there's a decent amount of plumbing to make this work. Like making Zap fire up in the middle of your pipeline and actually run properly and then shut down and harvest results is slightly non-trivial, but it's doable, and it gives you this kind of free results even if you don't really have any security tests, right? So it can be very powerful. The second mode is the active scanning mode, where you're using the spidering and you're using the kind of attack patterns and the fuzzing that are within Zap to truly dig into your app and do things. And anybody who's ever tried this also knows that you don't really get that for free either, unless you train it and you set it up properly and you teach it how to log in and you do things. I've had clients that are like, oh yeah, I ran 100,000 tests against my app and it was totally secure. I got 0 results. I was like, 0 results? Really? And you know, it failed like 10,000 times against the login page and found nothing. The real ironic part was there was actually a cross-site scripting problem on the login page and it didn't find it. So they weren't doing it right. Anyway, but again, this is where it's about this stage where you're doing your functional tests that doing these application security tests can start providing some benefit from you. And if you can automate these and time in your pipeline, then it's not a once a month or once a quarter pen test that you're running against this. It happens all the time. Now, anybody who's run these tools also knows that, well, these can take a while, right? The bigger your app is, the deeper it goes, it can take a while. And you may have to come up with ways to limit it. Again, kind of back to your SLA comment, which is, I don't want to run that for 4 hours against my app in every build. But I might be able to do a basic scan of some of the major, and it might actually be better to do a bit of a capture replay, just go through and test these pages and fuzz the crap out of them, as opposed to spider the whole app sort of thing. So you're going to have to make some choices as you set these up. Come on, go. Come on. Oh, it's a computer that works. A little bit of a sidebar. Okay, a little bit of a sidebar. Dealing with exceptions and false positives, right? So as you're running all of these tools, one of the things you're going to find is you're going to come across things that you decide aren't real problems. Oh, it's complaining about this line of code. It's not a real problem, right? So one of the points earlier, hard gates, soft gates, right? You want your pipeline to be binary, which is pass or fail. It's either good or it's bad. You don't like maybes, right? You don't want something that requires you to have to go look at a bunch of logs to decide whether it's good or bad, right? So when something fails, you need to sit down, you need to analyze it, somehow account for it, fix it, mark it a false positive or something, right? So you either fix it, you swallow it, or somehow you got to make it stop complaining, right? So a lot of OWASP, perfect example. You're doing a dependency analysis. You decide, oh, well, based on the way we're using this library, it's not relevant to us. It's not the vulnerability that's in it is not affect to us. Please, tool, stop complaining about this, right? And you need some mechanism within the tool where you can say, stop complaining about this particular thing. And there's situations where like, oh, this is never relevant to us. Don't ever tell me about this anywhere again, or it's not relevant in this particular instance, right? And all of the tools have different ways of doing that. And you want to be able to handle that, wrap it in, and make the pipeline stop complaining about it next time, right? Sometimes it's tempting to go into like the SonarQube interface and click on something and turn it off, but then you run into all kinds of branching problems, and then, okay, that's great for that branch, but not for other branches. So my point is, I can't tell you every single tool out there, but there are ways to do it. The closer you can make that mark to the code as it lives on its branches and its changes over time, the more likely it will remain accurate. So if there's something you can check into a branch of code or mark a line of code that says, I have audited this, I have analyzed it, it is not a problem, leave me alone, that's great. It goes straight in the code. Next time you see it, if you ever see it again, you're like, oh yeah, well, Joe Blow on such and such day made this change, right? So you're gonna want a way to do that with all of these tools. It's just one of the pitfalls we learn over time is you gotta make the tools stop complaining about things, right? So you may have to set up tools and thresholds. You need to work in the general pipeline framework you're going to come up with. You're going to need ways to do that. Moving along, real-time monitoring. Again, monitoring is not really a quality gate in many ways. It is something that picks up when code is done and it's ready to move on, right? Once it goes live in an environment, everybody talks about monitoring in production, right? Everybody monitors production, or let's pretend everybody monitors production. Often one of the things that you want to do as you're setting up your DevSecOps processes is you don't want to monitor just production. Let's monitor our pre-prod and our development environments as well, so that we don't have to wait until things are in production before we find these bad things that these awesome monitoring tools are finding, right? So you want to set it up so you're monitoring all your environments if you can, right? And the different tools that kind of play into this, stuff like log aggregation and scanning, right? This is where tools like Splunk, Kibana, Logstash come into play. Perfect example. One of the security requirements is thou shalt not log PII, right? Don't log social security numbers in log files, for God's sakes, right? Bad, don't do it. Everybody agrees with it, except for the developers were never told, right? So now you have a piece of code somewhere, receives a REST request, and all it does is like it craps out an exception and it dumps the entire request into a log file. Well, the request response has PII in it. It has stuff in it that's not supposed to be logged, right? Well, if nobody ever looks at that log file, you're logging PII, right? You're logging social security numbers in a log file. If you don't discover that until you get into production where you're actually bleeding real people's data into a file, that's bad. Where, on the other hand, like on the project I was just on, if you discover it in the dev environment, you're like, oh, our Splunk log's looking for words called social security number or SSN just fired in dev environment. We got to go fix that piece of code to stop logging this kind of stuff, right? That's a perfect example of why you want to log or monitor logs, not just in prod, but in all your environments, right? Container and host monitoring, I kind of talked about that. You want to be scanning the way you're building your host, the way you're installing stuff to make sure that you're doing it right. Right? You don't want to make the same mistakes everybody else gets hacked on for, right? Performance monitoring, general availability. If you can start seeing things like, spikes in traffic that, oh, maybe we're being attacked, or degraded performance, right? You start finding web times that fall off. You know something's going wrong. You know what to look at. Ultimately, this wraps it up into typically what we call SIEM products, security information event management. Again, lots of good tools out there, both open source and commercial. Good things to do, but again, slightly outside the pipeline, if you will. Which comes to kind of one of the other sidebars. Monitoring tools typically satisfy a lot of aspects of security controls. How many people in the room here work in some kind of compliance capacity? Again, compliance a lot of times is box checking, right? It's making sure we're doing things. It's justifying that, oh, you told me I need to do this. This is how we're doing it. It usually means putting controls in place, right? A lot of these tools satisfy some need for some controls, but not all of them. I mean, one of the controls somewhere is like, thou shalt deal with OWASP top 10 problems. Okay. It's the vaguest kind of compliance requirement everywhere. And you're like, okay, I have a tool that says OWASP in it, right? The point is, a lot of times you're going to need to put analysis into this of like, oh, how are these tools helping? Sometimes it's even like, oh my God, why do I have 400 tools when I only need 20, right? Or something like that. So you will go through some analysis at some point where you really want to think about how are these tools actually helping with my compliance? Or do I just have tools for the sake of tools because tools are cool? Ideally, what you want is, as you kind of assess compliance, what you really want is you don't want to have to assess the compliance of your software on a regular manual basis, right? What you really want is you want a compliant pipeline, which is, I've gone through an audit. I've told you I have all the stuff in my pipeline that assesses and guarantees good software, which means if my pipeline is green, my software is good, right? So that if the pipeline goes red and something fails, I know I have a problem, right? And then once in a while, you go through periodic manual audits of ensuring that your pipeline's still doing what it's supposed to do, right? This allows you to accelerate the speed of your delivery without having some manual audit blocking your way to production every time you try to build software. So pulling it all together, one of the things I complained about earlier is the more tools you have in place, the more results you have strewn over everywhere in your enterprise, right? And at some point, you want to get an idea of, well, am I good? Am I bad? If I am bad, what's bad? How do I find it? How do I fix it? What is my real health, right? A lot of times it's very difficult to track down and read and debug things, like even stuff like I made fun of retired DCAST. It's a horrible results file that comes out of it, right? But the tool itself throws out a threshold, which is if you are higher than a 7.5 CVSS score, fail to build, right? That's good. That's binary. But sometimes if it does fail, you got to go find the results, figure out what failed, and deduce it and fix it, right? So that's part of the challenge, right? So ultimately what you're going to need is to assemble a lot of data sources into some digestible format that you can use. And again, there's tools out there that can help you do it. One of the ones we used was Hygeia. Hygeia is an open source dashboarding framework that was put out by Capital One. In all honesty, it's a real pain in the ass to set up. It's getting better, but it's difficult and it's challenging to set up. But one of the things about it is it's extendable. right? So it has these extendable collector things where what we were able to do is we took the OWASP dependency check results and we took the retire.js results, which are effectively the same thing for 2 different languages. And we were basically able to pull those in and digest it into a framework so that we had kind of this open source panel that would pop up and it said, you have 5 highs, mediums, and lows, and here's like the spit out list of them, right? So we were able to kind of normalize those results, get them on a dashboard pane where we can see the general health of it. And I'm not going to go very far into this, but I will warn you that the more tools you get in place, the more of a problem this will be long term. I'm sorry?
Have you guys tried ThreadFix?
ThreadFix is the one that ingests into SonarQube, right? It can digest.
No. It's its own.
Oh, is it?
It's the Denim Group's ThreadFix.
Oh, I haven't tried it then.
There's a whole set of tools in this space, commercial tools that would pop
Again.
up. There's a lot of them.
There's a lot of them. ThreadFix is not one that I have used yet, so that's cool. I'm very interested in it. We used, oh, I know what it was. It was a piece of ThreadFix that can interpret 4 to 5 results and spit it out in a way that we were able to ingest into SonarQube. That's what it was. That was a bit of a magic show, but it works. But again, you start like none of these things I've told you how to do that sound easy are actually easy. It takes some work and it takes time to get them in play, but they enable what you're trying to get to, which is continuous security. And what I'm really, and the kind of the home run of all this is none of this works very well if you can't get people to work together, right? What we're trying to do is, again, the whole DevSecOps thing is get people from development, security, quality, and ops all to actually work together instead of against each other, right? That's what the whole idea with DevOps was, to get the development and the operations groups to work together. And then people were, well, that really just meant dev and QA and ops, because QA was in the middle and testing is important. And then they realized it's like, oh, well, yeah, the security people are just like QA people, right? They have a vested interest in everybody wants highly secure software, right? So it's about making these people work together. And one of the things that we need, that I've found over time, is ideally you want team structures that encourage kind of collaboration and delivery with the common interest in mind, right? So ultimately what we need is we need engineers who understand code, build, deployment, test, and automation. And when I say engineers, I mean security engineers, right? You can't have somebody who just understands security but has no idea how software is built or how to read code, right? You can't be a very effective security engineer, in my opinion, certainly in this DevSecOps world, if you don't understand at least a little bit of what the people around you are doing, right? You can't survive with just compliance checkboxes, right? I've had, unfortunately, some very not knowledgeable compliance auditors come and ask me questions about how the software is built, and I go into a tirade about how it's built and what might be wrong with it, and I get this glassy, doe-eyed stare, and they go, he sounds like he knows what he's talking about. Okay, check. No, you need people that are respected and can ask you good questions and give you respectful answers and stuff like that. So you need engineers who understand this. And half the battle really is getting these teams to work together and not against each other, right? When you have a security team, you want security consultants, not security police, right? You want security people that are helping you build secure software, not just telling you you're an idiot and you're doing it wrong, right? You want contributors, not naysayers, right? Instead of, oh, this is broken. Here, this is how we're going to fix it. Instead of, it's broken, good luck, right? We had a security team on the last project that drove me crazy for a while, because all they would do is run a tool, copy and paste what the tool told them, put it in a JIRA ticket, and assign it to somebody to fix. And by the way, not give you a link back to the tool of where the results and the actual details were, right? Not helpful, right?
Also comes with a lot of high rate of false positives, and I've known teams that routinely create tickets for false positives.
Right. And then the developer has to first waste all of their time just trying to get the details of what that actually meant, and then realize, oh yeah, this is not actually a problem. So yeah, I feel like I've been there, Ben.
I think it was the same thing.
Anyway, you want to build a culture of security. You want to expect every build to be secure, and as soon as it breaks, somebody goes, oh, that broke. It wasn't broken yesterday, it's broken today, so something changed, I'm gonna go fix it, right? That's the culture you want. So the way I typically describe this and what I found to be useful is, I guess, what I will call horizontal technical guilds, although I hate the fact that the way I use the word guild does not match up with Spotify model, so whatever. The whole point is you get some group of specialized professionals working together to call what I will call cross-team problems, right? And these guild members, when they are in team, meaning actually assigned to a team, because I have some situations where I have them assigned to a team, they are focused very much on specific team needs, right? But then I also have the horizontal group of them where they might not be on a specific team, and their job, these dedicated guild members, are to support the kind of cross-team needs. Because I don't have one team, I have 10 teams, or I have 50 teams across my enterprise, right? And that the guild is responsible for kind of establishing these cross-team needs. So, for example, right now I have one vertical team there. Pretend there's 30 of those, right? And on every one of those teams, I have a test engineer, a DevOps engineer, and a security engineer that have very specific knowledge and expertise where they come from. Very much like, quite frankly, a developer has very specific expertise, right? Then outside of that, I also, for the quote, let's say security, or I'll talk DevOps because I live in that world, right? For my DevOps team, I also have some DevOps engineers who are responsible for DevOps tool maintenance, like keeping the Jenkins server up and running, et cetera, et cetera. I'm a lead for that team. I'm in charge of managing them, right? Well, the guys that are actually on the team are responsible for the DevOps problems on a day-to-day basis for that team. The same holds true for the quality world. And for the security world, often what we have is we have a security team, right? There's 4 guys down some hall somewhere. They're the security guys, right? And they're not assigned to a team. They're just the police, right? So what we need to do is we need to figure out how to get a security guy assigned to a development team. The immediate problem you're going to have, there is no way you're ever going to have enough security teams in any organization I've ever seen, security people, to put one per team. But the point is, you're going to have a representative who is assigned to that team, that even if Matt's my representative, and he's handling each one of these, tables as a team, they have to know him as a person. They have to have a person they can go to, a person who's on their side that's helping them solve their problems, not just be the bad guy, right? And that's one of the struggles. And it's hard to do, and I've rarely seen it done right. But when it does work, you end up with people that at least have a relationship, right? It's about people. I mean, DevOps is about people working together. Like doing security and continuous security and DevSecOps is about people working together. And if you can't build a relationship and you never see these security people, it's not going to work, right? You have to build that expertise. You need a central management group who's managing tools and standards. Like if you've got Fortify servers, right? You need somebody to manage those, right? They're part of your security team. But you also need the engineers who are working with the individual teams, helping them solve their problems, not just beating them over the head with a Fortify club once in a while, right? So it's important. So to wrap it up, some of the key things I want you guys to walk away with, right, is that you certainly need to develop a product that has security built into it. And you need ways to determine that, right? You need ways to build it in, and then you need a set of tools and a set of processes that help you assess whether you're doing that correctly. You want to start with the simple free tools if you can. Right? If you got lots of money, you want to go buy expensive ones, sure, go waste your money first. But start somewhere, right? Drive towards this continuous so it executes as part of your build pipeline as often as you can. Because ultimately what you're trying to do is develop a culture with security in it, right? You want every build to succeed. You want people to expect their software to be secure, not roll their eyeballs when it's time for the security audit. Right? And that's kind of it. That's my point. Thanks for your time. What are your questions?
So when you're doing gating,
Gating.
it assumes that the security vulnerabilities you find are static. Happens when you have new vulnerabilities discovered after it's passed the gate.
Yeah, so the question for anybody who might not be in the room is after you get past a gate, vulnerabilities aren't static, they're changing all the time, we're always discovering new ones. It's why, quite frankly, monitoring comes into place, or tools that you can use to rescan your applications once in a while to discover new things. As it turns out, static code code vulnerabilities, they don't tend to blur very much. But the known CVEs and all that stuff does, which is why you have to have some mechanism to rescan those. It's actually why some of the container scanning tools, Nessus, OpenVAS, things like the container scanning tools regularly pull the containers apart and look at them. And when they get in monitoring mode, they're actually really powerful. and very helpful. I actually don't know about like the IAST and the RAS products of whether they do that as well, but there's like they absolutely, that's a great opportunity for doing that kind of stuff. So
I mean, in view of the component vulnerability.
Can you put up the key takeaways again?
yeah, absolutely. And I guess, I mean, I can share these slides if we have a place to put them on the meetup or whatever.
We recorded it.
Oh, you did?
so
Oh,
we
excellent.
can
Cool.
post it.
Okay, that's fantastic.
We'll post it in the meetup.
Yep.
Post the link so everybody has it.
So when you're dealing with, like when you're setting up your DevOps pipeline, DevSecOps, what are the low-hanging fruit that you first take on so that you start snowballing?
Yep. Yeah, so low-hanging fruit when you're setting up, certainly the static code analysis, that's the first one. The composition analysis is the second one, where you're doing your component analysis to make sure you're not pulling bad stuff off the internet. The next hardest one, quite frankly, is stuff like the pen testing tools, like using Zap or something like that. If you don't do a pen test very often or ever, there are things you're going to find with these tools, and they're eye-opening the first time you ever run them. And those are the ones, and those are the three that we most often put in place. And quite frankly, not to be forgotten, like some kind of monitoring tool. Even if what you're doing is just performance and resource monitoring, where you're like, oh crap, I'm running out of memory all the time, right? Some aspect of security is availability. And if your software keeps crapping out, it's not very available, right? And it also means it's also very subject to basically any kind of attack that just consumes resources. So that's the quick 3 or 4 I can think of. Came back. I don't know how to enforce encryption best practices in a pipeline. Like, I haven't really thought about that. Yes, you should encrypt it. Like, some of it is stuff like, if you run any of the tools and you're running non-encrypted transport, like you're not using SSL and HTTPS type stuff. Like, a lot of tools are going to start complaining about that almost immediately. As far as not using encrypted data,
If you're using the cloud like with Amazon, it can handle, or it can abstract it to a layer that you don't have any control over. So you can put all your passwords in vault. You can lock things out to very, very specific users. So that even actually an admin couldn't view a key after they put it into a specific bucket.
Some of the scanners like Twistlock and all, they alert you when you're doing something wrong, like leaving keys in the image or stuff like that. Or
Twistlock will complain a lot about a lot of that stuff, which is good.
you can run against benchmarks, and also there was a tool where you can redefine your own compliance, whatever it is.
Right. Yeah, I think a number of them you can start defining rules. Even Twistlock, you can create your own rules for it. So in a lot of the tools, I think will do that. But as far as kind of abstractly, there's a lot of best practices about when to use various forms of encryption. Some of the tools, and a lot of these really classifies the monitoring and the vulnerability scanning tools. We'll look for that kind of stuff. So yeah.
So do you have used, like you mentioned, microservices? So have you used dynamic testing tools and integrated that with microservices?
Yes. Yes. And so we've done that. We didn't get far enough to do it on the current project yet. But we've done it on other projects where it's basically as each element of the pipeline for whatever piece you're building, you can tie into it to basically doing stuff like firing up Zap and using it as a proxy for some of the tests. And we've done that successfully. We've also set up multi-branch pipelines where it can launch Zap and actually put it in attack mode and generate some results that way as well. The trick with that, though, is because each surface is different, unless it's a really generic scan, you have to prime each one of those with teaching Zap kind of how to get access to your app, at least to get the entry point in before it can do anything. So there's more work involved, which means you need to externalize that priming, if you will, the project or whatever defines it, in a way that gets stored with the code and evolves with the code. It's kind of going off on a CM release transit. But one of the problems with a lot of stuff is as you do a lot of this stuff on branch-based development, you branch, you make changes, you merge, you want your tests and your security and your everything to live with that branch. So your code evolves on the branch, so does all the test and the pipeline stuff, right? So this really starts getting into pipeline as code, which is that you want your pipeline to kind of evolve with your code, right? So it's complex. It's not an easy situation, but those are some of the things that you strive for.
One easy tool to run with it is IS.
Mhm.
Like, every time you do it,
Yeah.
it runs along. And
Yeah. Are
for that incremental thing.
Yeah. Are people aware of any decent IS open source tools at this point? Any free ones? I think they all cost money because they're all pretty powerful.
If your product is open source, I think Contrast
Yeah.
aims to cover your open source.
So, okay.
Have you ever had to automate the verification of the 853 controls?
No.
Platform scanning?
Yeah, you're talking about the NIST 853 or 800.53. No. So one of the things that helps with that I didn't talk about at all, was it InSpec is a tool that was originally kind of developed by a lot of the guys at Chef. InSpec was set up so that you could create Chef type declarative rules that, and I think they made an 800.53 set that would basically, you could run it, and just like you were running Chef to install software, it would run and it would basically go in and examine a machine. And it was specifically designed to spew out documentation that was built for compliance docs. So look for something called InSpec, INSPEC. Go look it up. And I never got a chance to use it, but it showed a lot of promise, and I do know people who were using that who were very happy with it. So it's worth looking at. But that would be another very good example of something you could tie into a pipeline, because every time you launch or configure a machine, you could easily run your rules against it. In the back.
So there are so many tools, and each tools would need to be owned, right? So from planning perspective, what's the, you know, you always have limited.
Yep.
So this cycle usually would you say, okay, within 6 months I step up something, or how do you?
Yeah, and I don't think there's a magic or an easy answer to how hard or how long it's going to take, because it's completely variant per tool. My only suggestion is use, a lot of the mentality around agile planning and risk-based analysis, which is, okay, what's most important to me and why? Right? Sometimes sitting down and going, okay, doing a little threat analysis, which is what's most important to me. Am I doing this because of compliance reasons? Am I doing it because I'm justifiably afraid of these kinds of threats? It will drive you in the direction of, okay, what's the most important aspect of security? For me, it will drive you in the direction of how am I going to make sure these things go wrong? And it's going to be a decomposition. And there's no easy answer, but you're going to need some smart, knowledgeable people who are familiar with the tools and the landscape and the types of problems that go wrong to try to help you figure that out. And that's not a very good answer. It's very vague, but it's unfortunately kind of it.
Can I just add to that?
Yeah, go ahead.
Go read some of the industry Horizon breach report.
Yeah.
Which are the ones that cause, what are the things that cause the breaches?
Yeah, that's a good point.
Deal with those. Unfortunately, as much as it, kind of sucks, a large majority of the breaches are because of known exploits for third-party components.
Yeah, it's